We have another example problem here. Two stereo speakers mounted 4.52 meters apart on a wall emit identical sound waves. You are standing at the opposite wall of the room at a point directly between the two speakers. You walk 2.11 meters parallel to the wall to a location where you first notice that the sound intensity is much less. If the wall along which you are walking is 13.3 meters from the wall with the speakers, what is the wavelength of the sound waves? Okay, so first I want to draw a sketch so I have a picture of what's going on here. So I have two speakers. They're 4.52 meters apart on a wall. They're emitting identical sound waves. So these waves have the same wavelength, same frequency, same amplitude, and they're in phase. We are standing on the opposite wall, and it tells us at a point directly between the two speakers. So I'm going to come directly between the two speakers. This is where we're starting. We're on the opposite wall in the middle. We're going to walk 2.11 meters parallel to the wall. So whether I go left or right doesn't really matter. All I know is that I go 2.11 meters in either left or right. So this is where I am now. This is where we're at. And at this location, this is where we first notice that the sound intensity is much less. Meaning, this is the first destructive location. So if the wall along which we are walking is 13.3 meters from the wall with the speakers, so this distance is 13.3 meters. We want to find the wavelength of these sound waves that are destructively interfering at this location. All right, so since the waves are identical, destructive interference is this condition, or equation, I guess I should say, of delta x is equal to this quantity of m plus 1/2 times the wavelength of the sound waves that we are listening to. Since this is the first location, and m can be 0, 1, 2, 3, so forth, the first location of destructive interference occurs when m is its smallest value of 0. So we can actually take this one step farther and say that delta x now that we've moved to this new location, delta x is half of the wavelength. So the wavelength is what we're solving for. That's going to be twice delta x, 2 times delta x. Now delta x is not 2.11. Delta x does not represent how far we walked. Delta x is the difference in distance. So this left speaker, the sound has to travel a distance of x1 to get to us. The right speaker, x2, is the distance the sound has to travel to get to us. Delta x is the difference between these, and just the absolute value. I'm going to write it as x2 minus x1 because I can see that x2 is larger, and so when I find x2 minus x1, it will be a positive number. Okay, that's what we have to figure out. All right, so I have here some right triangles. x2, for example, I know this side is 13.3 meters. this side is going to be whatever half, because since we were in the center to begin with, so this side, from the speaker to this middle location would be half of that 4.52 meters. But with the way I've drawn it, I then also walked 2.11 meters. So that horizontal distance is oh dear, what did I just do? I don't know. Sorry about that. Is 4.37 meters. So that's the distance from this right-hand speaker to this, just horizontally to where we are now. So x2, just using Pythagorean theorem, x2 is the hypotenuse. So one side squared plus the other side squared is going to be x2. Square root 37 squared. 13.9995 meters. And I'm going to go ahead and keep those digits for now because we technically have 3 sig figs, so I want to keep more than 3 for the moment. Similarly, x1, we need to figure out this distance right here, which would just be 4.52 minus the 4.37. So this side, 0.15 meters. This side is the 13.3. So I expect we'll get essentially 13.3. But technically, Pythagorean theorem, that one side is so incredibly small, we are getting x1 to be 13.3. If I go out the same number of digits I did on the other, I get 0.3008. And I might as well go out to the same location. 13.9995 minus 13.3008. Delta x is this difference. And I'm using all the values in my calculator since my calculator is keeping track of all of this for me. So delta x, 0.6987 meters. That's how much farther the sound wave from the right-hand speaker is traveling to get to us compared to the sound wave from the left-hand speaker. So now coming back to the wavelength, we already reasoned through that the wavelength needed to be 2 times delta x. I'm going to multiply this by 2. Now I will round, since I'm at my final answer. Since the 9 is going to round up, we find that this wavelength of this sound wave is 1.4 meters in order to destructively interfere at that specific location.